Okay, I assume everybody can hear me. This is Mike Ali, Chairman of the Programs Committee, and again, want to welcome everybody tonight for the lecture and in-person lecture. And again, we always thank Applied Physics Lab for their support, helping us produce the event, providing both the facilities and the audio-visual video staff. Tonight's door prize is Model-Based Systems Engineering by our speaker and his co-author, Scott. As usual, we'll be raffling this door prize to one lucky attendee, but you do have to be on site to win. You should feel free to type any questions into the chat window during the presentation, and then it's up to the speaker to decide if they want to answer questions during the talk. Otherwise, we'll get to your questions at the end of the talk. And tonight's presentation is Engineering a Better Tomorrow, SE Vision 2035 and Beyond. With David Long. David has spent over 30 years helping organizations increase their system engineering proficiency while simultaneously working to advance the state of the art. David was the founder and president of Vitech, where he led the development of innovative industry-leading methods and software to engineer next-generation systems. He co-authored our raffle prize tonight, and he also frequently delivers keynotes, tutorials, and workshops around the world. He's an Incose fellow and an expert systems engineering professional, and he was our 2014-2015 president for Incose. And he's currently the president of Blue Holon, Inc. So with that introduction, I'll turn the podium over to David.
Very good. Thank you so much. I regret that I can't be with you in person. Steve, you're in a much nicer place in Florida. I'm up in Hoboken preparing for the Conference on Systems Engineering Research, but I am pleased to join you tonight. 1 second here as I pop open my chat so that I can see what goes on. I appreciate and welcome the side chat as we run through. I might actually respond to 1 or 2. I might even heckle you in response, so feel free to add your comments. I'll play along as we go along. So certainly, I think we all feel that life is getting more complex every day. If we listen to the news, I know if you listen to the news over about the last week, we certainly wish the pace of change would slow down. Some of it on the financial fronts, some of it on the AI front. But the reality is we can't control complexity. We can't control the pace of change. We can't control the fact that our customers are demanding more and more of us every day. What we can control is our response. So as technologies advance, as complexity grows, the approaches that got us here won't get us there. We know that yesterday's approaches alone will fall short of what we require. If we're to succeed in addressing the challenges of today and tomorrow, how do we evolve? How do we transform? Do we have to reject what got us here, or can we build upon those foundations? Now, Incose Systems Engineering Vision 2035 seeks to inspire and guide the strategic direction of the systems engineering community. How can we leverage the insights there as we strive to engineer a better tomorrow? Hold on tight, the future comes quick. And so we will move fast as we move through this talk. When I look to the future, I like to look at 2 points first. I like to look at where we came from and where we are today. That may not give us a linear path to the future, but it gives us a sense of vector, a trajectory, and we can determine how we need to adjust course. It at least informs the path forward. So if we think about the good old days, the golden days of systems engineering for many, you're thinking to the 60s, perhaps the 70s, when we put man on the moon, we put a space station in orbit. We also put missiles in silos, tanks on the battlefield. But if you step back and think about words that characterize the systems and the systems approach, you'll have words such as electromechanical. That was the technology. These were standalone systems. They typically were long-lived systems, stable technologies, fresh design. How many of those words apply to the work that you do today? Not many. When we think about systems of today, we think of things like the T-7A, engineered by Boeing and Saab and produced in 36 months. as opposed to the typical design cycle for an airplane. We think of connected, autonomous, electrified vehicles. We think of Boston Dynamics robots dancing around the holidays to Do You Love Me? If you haven't seen it, go to YouTube, Google it. And so we sense all of this radical change, a great deal of electronics, a great deal of software, a great deal of interconnectivity and rapid evolution. Go back in time about 10 years, and you will find Incose Systems Engineering Vision 2025. And in that chart, in that vision was this classic chart that showed 6 challenges that any organization involved in systems, knowingly involved in systems, was experiencing. I've extracted 5 here. These words from Vision 2025, published in 2014, sadly are still valid today. Mission complexity then we felt was growing faster than our ability to manage it. As much as we strive to architect intentionally, we recognize that most systems were assembled. They had architecture via assembly with many negative connotations. So we had systems that were brittle, difficult to test, complex, expensive to operate, the antithesis of what we wanted. As systems ran through their life cycle, as you passed from team to team in life cycle phases, we knew that we lost knowledge. We knew that we lost investment. We knew that as we tried to engineer across.
Jeff,
All right.
Okay, sounds all right. So I guess you can continue, David.
Very good. Hey, we talked about complexity. We talked about change, right? And we have to be a little bit resilient. So this is good. Thanks everybody for joining back in. So I was describing the challenges cited in Vision 2025. As we were logging out, as we were getting disconnected, I mentioned we know that we lose knowledge and investment through the life cycle. We know that we do not learn effectively across systems. And we know that as much as systems engineers and program managers who should be in it, who are in it for the same thing, which is delivering value to the customer via the system of interest, oftentimes end up in opposition as systems engineers focus on technical performance measures, program managers focus on schedule and budget. So why does this happen? Well, the fundamental culprit is an explosion not in complexity singular, but in complexities plural. If we look to the graphic on the left, if we look to the graphic from Vision 2035, we see 6 global factors. The first 2, sustainability and an interdependent world, one might communicate as new. They're not new at all. It's actually a greater awareness of our impact on the world and the interconnectedness. 3, 4, and 5, digital transformation, Industry 4.0, Society 5.0, smart systems, those are reflections of changing technology and our desire to leverage that power. But with that power, we are injecting complexity ourselves. And 6, well, that's the byproduct. The words on the right reflect the ways that we're seeing complexity. We're attacking bigger problems. We're attacking more audacious problems. We're injecting technology complexity into our system. If you're talking about a mechanical system, then it only directly impacts that which it touches. So a brick can exert force on the 6 bricks next to it on the various faces. But if you're talking about electronics or software that weave their way, snake their way through a modern system, you have the potential of a butterfly effect. A small change in one place can have a small dampening change throughout, or can have an amplifying change. Project team complexity, we can no longer gather everybody involved in a major system in one room. The supply chain wraps around the world. Dynamic complexity, the pace of change is so great that technologies and the context changes as we try to engineer a solution. And cycle time, we need to do more in less time. So complexities plural is the challenge that we face. And an example of that are trying to embrace the sustainable design goals from the UN. We're no longer talking about engineering only at the product-centric level. We're not even talking about engineering at the enterprise level. We're talking about engineering at the societal level. And as my colleague Ad Sparius once taught me, hey man, a toaster ain't an economy. You can engineer both, but the way you engineer them is very, very different. There may be fundamental principles that underlie both, but an economy and a toaster are two very different things. We can also then look at enhanced expectations. Industry 4.0 and the change, the drive on products to cyber physical systems. But for me, even more interesting is Society 5.0, the vision of a human-centered society that balances economic advancement with the resolution of social problems through a system that integrates cyberspace and physical space. How do we leverage technology in a human-centered world? That's a different mindset. It's not a product-centric mindset. It's a human and a society-centered mindset. And again, our stakeholders, not just our customers, our stakeholders are demanding more and more every day. I want it to be sustainable. I want it to be simple. I want it to be smart. I want it to be secure. And engineering for one of these 10 things is difficult. Engineering for all 10 simultaneously, can you make it simple, smart, safe, and secure? That becomes pretty complex. So what are we going to do? Well, we could throw our hands in the air. We could play the ostrich, bury our head in the sand, but that's not who we are. We're engineers. We see a better tomorrow. Yes, we may build in safety factors because we know things aren't perfect, but we aspire for something better. We think we can create a better future. So how do we respond to that challenge? Well, this is where Vision 2035 begins to lay out some aspects. I'd like to lay out some tools that we have in our toolkit. And then after we go through this, we can start to cast some roadmaps and perhaps put into place a few journey maps for the future. So the first thing in responding to the challenge is recognizing that we don't have to engineer tomorrow's solution with yesterday's technology. Apollo may have put us on the moon. Artemis may take us back to the moon, but we're going there in two very, very different ways. The technologies that we include in our systems, the technologies that we use to engineer and manufacture our systems are very different. First and foremost in our mind is certainly digitalization and the advances in computing power, in storage, in big data and analytics, in AI and ML, in virtual reality and augmented reality. We think about the power of electronics and software every day and the tremendous impact that it has on our systems and on the way that we engineer. But it doesn't stop there. We also need to remember advances such as additive manufacturing and the fact that we can produce things in different ways than we ever could before. And by the way, composite materials and nanotechnologies. And how about biotechnology advances and everything that's happening at that level? These are simply three representative technologies. But as we think about grappling with the pace of change and the scale of complexity, let's also remember we don't have to engineer tomorrow's solutions with yesterday's technology. Digital plays a key role to us as engineers. From systems engineering, as we talk about the digitalization of systems engineering, we generally talk about model-based systems engineering. Well, there's also model-based engineering, so I genericize it as MBX, model-based everything. But there's also digital thread, digital twin, digital engineering, digital transformation, So there's also DX, the digital everything. And if we look at this, it's allowing us to do several things. It's allowing us to bring the power of computing, the power of storage, but also go back to that Vision 2025 challenge where we said, as we hand off from team to team, as we progress through the engineering life cycle, we lose knowledge and investment. Well, now, through better use of digitization and digitalization, better management of data, we can connect the engineering life cycle. We can at least reduce the loss of information. We aspire for a seamless exchange as part of a digital engineering environment. We can go beyond the engineering life cycle and really connect from concept to operations. Now, the moment that we do this, we have really changed the scope. And we're talking about transforming not the way that we do systems engineering, but transforming the way that we do the engineering and maintenance of systems through life. It deeply involves the human and the human-machine interaction. It involves them up front to better understand the problem, more participatory methods, and better leverage and elicit their insights so that we engineer to the right problem space. It involves human-machine interaction throughout the engineering process. It involves human-machine understanding so that we design machines that can better operate in parallel in support of, with the support of their human partner. But it's also all about data. It's about how do we use simulated data up front, observed data, and experimental data throughout. How can we better quantify performance and risk for non-deterministic systems? How can we build the right feedback loops to better leverage data? Now, the moment you talk about data, you also then begin to cross into leveraging assisted intelligence, augmented intelligence, automation, AI, and ML. We know that those technologies are only as good as the data sets that they're fed, which means data becomes the gold that we need. It is the oxygen for next generation systems. So how can we leverage those? How can we leverage operations and management and humans? How can we leverage digital? How can we leverage today's technology? I've talked about a whole lot of new things, but this all builds on a solid foundation. It's not about throwing away the systems engineering of the past. It's about building upon the right principles of the past. I didn't say processes, note, I said principles. So as we're leveraging the new technologies, as we're leveraging everything that data and digitization and automation bring to bear, we also need to figure out how can we quantify the underpinning principles that underpin the foundations of systems engineering. There is a theoretical basis to everything that we do. There is game theory, there's economic theory, there is decision theory. We need to bring those bodies of theory together in a cohesive way, not so that every practitioner of systems engineering understands all those bodies of knowledge. That's impossible. But so that we have tied the foundations together in a way that better equip systems processes and methods and tools so that as we digitize and digitalize them, as we augment them with machine learning, that we are combining this transdisciplinary set of fields in a cohesive way. In the 60s and 70s, the initial practitioners of systems engineering did this, I'm not going to say instinctively, but they recognized that they were operating in a transdisciplinary space. And they made sure that they reached out to the necessary experts in these fields to bring just enough insight to their system of interest. because they were dealing on a smaller scale, in less connected with different technologies, they didn't require as many bodies of knowledge, and they could get away with doing it on a principled basis. Because of the scale, because of the complexity, we need to move to a more disciplined basis that integrates these together. And that means that as we move forward, we have to embrace that we as practitioners are transitioning. This means that fundamentally, we must embrace transdisciplinarity. It's a really, really big word. But fundamentally, key in on the diagram in the lower left of this. As engineers, we are trained in our discipline. We become bigger and bigger experts, deeper and deeper experts in a narrow niche, which is wonderfully powerful. That's how we have advanced specific technologies. Then we have multiple disciplines where we bring them disjointly together to try to solve a problem. Interdisciplinary is looking at the intersection. Transdisciplinary is looking at how we bring multiple disciplines together with a connective tissue to look at a problem from multiple perspectives and find the right answer. That's what we as systems engineers need to do. Now, why do I emphasize this so much? Because as we go through model-based, as we focus on digitalization, as we advance our discipline, we tend to take our eyes off of the horizon, and instead of looking outward to be transdisciplinary, we tend to look inward at our own practices. And if we're not careful, we create systems engineering as a siloed discipline. It was never meant to be that way, and it can't survive that way. Yes, we can advance our own methods, processes, and tools, but we need to do so in a transdisciplinary sense. We need to remember that we are the technical connective tissue that glues the practitioners and glues the other disciplines together. In doing so, we also have to recognize that in the golden days of the 60s and the 70s, we were building fundamentally on a mechanistic mindset. Rather simple modularity, rather simple coupling between pieces of the system. Now we are highly connected and we are highly interdependent, highly coupled. That means we need to move beyond mechanistic thinking to a biological life sciences networked mentality. And we have to build the SE workforce of the future on yesterday's principles, informed by biological life sciences mentalities for the complexity of today. If it sounds daunting, it is, but we will only get there if we help the practitioners embrace transdisciplinarity and embrace the role that they have performing systems engineering, our job, in the engineering of systems, the delivery of new capability to address a business need. To do that, we as practitioners have to take a competency-based perspective. We have to see the big picture and what we bring to the table. It's not about the latest software tool. It's not about flying processes. It is about principles and systems thinking and life cycles. It's about professional competencies, because we have to be transdisciplinary technical leaders, being that technical connective tissue. It is about having enough awareness in the technology of a given system so that we know who to trust, who to engage, to understand the problem, to find the right solution. So from the discussion of technologies to digitization, to automation, to transdisciplinarity and principles and competencies, these are building blocks for the future. How do we assemble those building blocks into something useful? How do we start to realize what Vision 2035 lays out and position ourselves to better engineer the future? Well, there are multiple paths forward. There is our path that we have to embrace as Incose, and as a discipline. And there is your path as a practitioner, your path as an organization. Ultimately, if we're to move forward, we all have to move forward together. It requires industry and government and academia and nonprofits. We cannot advance and win alone. We have to synergize across the product level, the enterprise level, the societal level, and different practitioners so that we can advance the discipline of systems engineering, so that we can advance the engineering of systems while still tailoring for the specific needs of a practitioner and of a given system of interest. So what does that look like? Well, we know that we can apply systems engineering to a product. We can also apply systems engineering to an enterprise, and we can apply systems engineering to a transformation. What we need to do is we need to apply systems engineering thinking to the transformation of systems engineering. We have to understand the current state. We have to understand the to-be state. And from there, systems engineers know that context matters. If you change the context, the solution changes. So we have to recognize the new global context, the interconnected context, the sustainability challenges, et cetera. We have to recognize that we're playing within the so-called pestle factors: political, economic, social, technical, environmental, and legal. With that as our context, then we look first at the path forward. Number one, it's a human problem, which means we have to manage the culture change. Engineering and systems engineering may be aided by tools, it may be supported by technology, but it is performed by humans, which means if we want to change the way we do systems engineering, we must manage the culture change, because this is change on a grand scale, whether you're talking about the maturation or transformation of systems engineering. From there, we know that we've got to evolve the knowledge base and then work together to achieve this vision. How do we work together? It's practice, it's research, it's competency, it's education, it's broadening our application field, and it's establishing tools that help us do all this. Now, if you look at Vision 2035, you will find a number of roadmaps. Here you see a top-level roadmap that integrates the views, and it tries to reflect out a series of progressions. The outer ring is where we are today on applications, on practices, tools, research, and competencies. And then where do we try to be in 2035? 2030. Where do we try to be in 2035 if we're on a trajectory to realize the vision? But it's not roadmap singular, it's roadmaps plural, because there's a roadmap on how the discipline must evolve to support the broader application of systems engineering, the broader transformation of systems engineering. That is something that Incose needs to own and pursue in concert with IEEE and AIAA and the IET in the UK, and so on around the world. There is the enterprise roadmap that your organization needs to have, and that needs to be tailored to your domain and the problems that you attempt to solve. The way you engineer a toaster and the way you engineer an economy are two different things. And then you need to own your personal roadmap for how you will grow, evolve, and lead in this transformation. As we start to scale our individual roadmaps and our enterprise roadmaps, what do we look for? Well, we need to remember that it is not about doing systems engineering, it's about delivering value. Good systems engineering is always fit for practice. The way I do systems engineering on a system that is designed for 2 years planned obsolescence, the latest iPhone, for example, and the way I do engineering for a 50 or 100-year infrastructure project, two very, very different things. The way I engineer, if quality truly is job one because it is a man-rated system, is very different than the way I engineer if it's all about beating the other guy to market. So first off, as you're developing your roadmap, understand where is your corporate value? What does your customer value? These are business needs on the right. And what are the criteria that characterize your problem space and your technologies? That's the radar plot on the left. This also means that you need to be very careful about listening to a wonderful talk at IS about how organization XYZ is doing things, and then attempting to take their practices and apply them to your domain carte blanche. Because their culture, their problem, their business priority set is a little different. So be informed by other people, but don't try to take them and copy them and apply them. It won't work. So understand your business need, understand your context. After that, understand where you need to be for DX, digital thread, digital twin, digital transformation, digital engineering. Where you need to be and where you want to be are two very, very different places. And each step along that way delivers higher value, but it does so at higher cost. The same question needs to be asked for AX. Where do you need to be on assistance, on automation, on artificial intelligence? What is right for your organization? What is right for your system of interest? And where do you need to be on meeting the pace of change? Agile is very important for certain kinds of systems, not quite as important for others. If you are engineering something that is only going to be in the field for a short period of time, maybe you engineer it in a way that is disposable in a sustainable sense. If you're engineering something that's going to be in the field for 25 years, and the context and the needs are going to change, well, you've got to take a different attitude towards change, because you may be engineering it to last, but it has to evolve over that life cycle as well. My points here are, if you're going to engineer your way to the future, then you need to understand your context, and your context is different than someone else's. Once you have that understanding, then you can go back to the building blocks that we were talking about and figure out what your SE Vision 2035 roadmap looks like. As you have that roadmap, now you understand your business need, your product need, your focus, you can begin to transform your systems engineering ecosystem. But even more importantly, what you're doing is you're transforming your engineering ecosystem, because our job is to do systems engineering as part of a bigger engineering life cycle to deliver business value. Now, we will tend to think about, well, that means I need new tools and new practices. Yes. And we also need new education and training. And these need to be synergistic. It all is going to build upon change agents and a culture that enables the workforce of tomorrow. So as you're thinking about your engineering practices, you need to be thinking of education and training that is founded on systems thinking with good theoretical foundations, technical and leadership competencies, and lifelong learning, because the pace of change is not going to slow down. On the practice side, again, how agile do you need to be? How model-based and digital do you need to be? Where's your emphasis on resilience, reuse, human-centered design? Those have to be tailored for your problem and your organization, and then the tools will enable those practices. As we talk about creating a better tomorrow, you can talk about these areas. In the applications area, we're moving beyond product-centric systems engineering to embrace societal level problems. The UN 17 Sustainable Design Goals, Society 5.0. Systems engineering is going to deliver value across a much broader ecosystem. We already know it's not just aerospace and defense. It's transportation, it's green energy, and more. The practices have to change in a way that are much more resilient and adaptable to the changing environment. We know that change accelerates. Model-based and digital is a critical enabler, but it's an enabler to also help us better engage the human, to immerse the human on the front end so that we have a better understanding of the problem, and in the resulting architecture so that the technology and the human can better interoperate in order to each bring their best. Systems engineering has to sustain increasingly complex systems. As interconnection grows, as coupling increases, complexity will only grow. And then we have to recognize that we don't have the opportunity to engineer every new system from first concept. We have to embrace product line thinking. We have to embrace patterns so that we can engineer more rapidly, more effectively, and more efficiently. Tools and environments, trust, collaboration, interaction in a digital ecosystem, all very, very important. Research has to accelerate to underpin all of this. Whether you think that systems engineering is simply an art and a craft today, or if you think it's a discipline, it doesn't matter. It is relatively immature, and we have to rapidly mature it because systems engineering is what's focused on emergence on the positive side and unintended consequence on the negative. And we as the transdisciplinary guardians have to advance our foundation, or else we're honestly just stumbling around as we face more and more complexity. And how do we do it all? It's through competencies. Fundamentally, what we're talking about here through Vision 2025, 10 years ago, and now Vision 2035, is how we adapt the practice, how we adapt as practitioners, how we respond to and leverage technologies, responding to 21st century needs with a revamped, not a completely new, but going back to our foundations and building 21st century systems engineering that's fit for today's problems and today's context. It has to be knowledge-based. We have to put it on a new foundation. It has to be value-centric, because it's not about doing systems engineering for systems engineers' sake. It's about delivering value to the customer. And it has to be fit for purpose. We engineer a man-rated system and a system for obsolescence different ways. We engineer an economy and a toaster different ways. Remember, it's about harmony and balance. It's about recognizing our heritage and being open to change. It's about architecture, which gives us a framework for innovation and resilience, and it's analytics to bring the real engineering there. It's innovation, it's analysis, it's practitioner and practice, it's systems thinking, and it's systems engineering. Whatever we do, we need to keep those foundations in mind. And I apologize for that. And we have to remember that the world is going to continue to get more complex. Change will continue to accelerate. And the reason is that we as humans will continue to dream bigger dreams. Our job is to innovate, to advocate, to educate, bringing that systems perspective and fit for purpose systems engineering approaches to the systems challenges ahead. If we do this, if we embrace our role, we have a chance to tackle the wicked problems and truly expand and explore new horizons. And with that, thank you. We will move on to some questions. And Steve Sutton, it looks like you've led us off here. So let's see here, Steve. So Incose has influenced education and SE university education through ABET. However, the time delay to bring these influences to bear on university programs will be much longer than the changes that are taking place in society, industry, and government. Absolutely. How do we speed up the introduction of new concepts into university programs to match the pace of change in society? Steve, thanks for the softball to really open things up. That's an interesting challenge. To me, as we talk about systems engineering and the university environment, it's one of the biggest challenges that we have, because university environments are one of the most siloed areas, and siloed for very, very good reasons. The university environment is designed to create experts, deeper and deeper experts in narrower and narrower fields. And again, that's really important because that's how we advance technologies. That's how we advance the discipline knowledge. I think our challenge is not so much the introduction of new concepts into university programs. I think our challenge is increasing systems awareness, first at the engineering level, and second, if we can do so at the greater university level. What do I mean? Any engineer in the US has to engage in a capstone design experience. But I don't remember those capstone design experiences specifically talking about systems thinking and systems design. They do it implicitly. I think if we are going to equip engineers for the future, we need to graduate an engineering workforce that is built upon the fundamental principles, because if we can make them systems aware, then we can make them better partners in the engineering of modern systems. And then we can build upon that with a learning mentality. If we try to keep pace inside the university system, Steve, I honestly believe that the friction and impedance mismatch of the university will actually slow us down, and we will get further and further behind. Perhaps that's the pessimist in me, but I think if we can put the systems thinking and systems awareness foundation in place, then we can graduate practitioners who perhaps are a little more aware. All right. Dave Fadley, the 2035 vision is a huge challenge, which means critical collaboration with other disciplines is necessary. What's going on collaboration-wise with Incose and other organizations? I've not heard much over the years other than with PMI. Dave, unfortunately, you are exactly right. By the way, I'm going to stop sharing here and just go to screen so we can see some faces. So what I would tell you, Dave, is, in my opinion, Incose has made a common error in 2025 and 2035. And that common error was we developed the vision a little too much in isolation and then attempted to engage a little too late, which is an interesting problem for a body that should be connectors. We weren't necessarily great connectors throughout. So we didn't ask PMI and IEEE and SAE and others to engage their voices early. Where we are asking them to engage their voices is in the future of systems engineering, the initiative that we are using to realize Vision 2035. When that initiative kicked off, Incose did a very good job of inviting other organizations, academic, professional society, government, industry into the room so that they were partners from day one. You've heard a lot about Fuse over the last 6 months. It was a focus at the International Workshop. It's a focus in Insight. You're seeing a lot of energy on this. And one of the things that Incose is doing to make Fuse a reality is for every area in Fuse to recruit a non-Incose co-chair, because Incose is not going to do this alone. We, again, have to have SAE and PMI and IEEE and AIAA and others on board. We are only going to succeed in 2035 to the degree that this is a shared industry vision that's pursued, not one in isolation. Okay. So those were two good questions in chat. Let me open it up to non-chat and perhaps those in the room at APL if you guys have questions.
No, Dave, I think everybody, whoop. Be back. I think everybody in the room, there's no questions here. Any more from the virtual world?
Hey, Dave, this is Dave Fadley again. Just to follow up, I happen to have some interaction with IEEE Systems Council, kind of accidentally, and I was bringing up some stuff, and they said they had stuff a while ago and it kind of died out. So have you found now with I think it's a great idea, with the future, the future system engineering kind of fuse stuff. Have we seen people actively starting to participate in that, or are they still holding off?
So Dave, good question. And what I will say is, what I have observed from the outside is that it seemed to follow a bit of a sinusoidal curve. We started out with peak engagement with those other societies in the room in about 2018. And then we've started to see it fall off. And I think it particularly fell off during the pandemic, where each society tended to, again, look inward to their transformation of operations into a hybrid world. Coming out of the pandemic, we're starting to climb back up that collaborative curve. At the IW, everything that you heard about Fuse was Incose centric. Those were Incose leaders, et cetera. But I can tell you just from being in meetings over the last month, every one of those Fuse leads is now looking for an active co-chair partner in another society. So this is the time where they are reaching out to IEEE, to SAE, et cetera. And if you've got informal dialogues, let them know that Incose absolutely wants to engage, and we want to bring their insights in as we pursue the future of systems engineering. So we're starting to come back up that collaboration curve.
Okay, thanks.
Thanks. Go ahead, Grace.
I'll try to unmute. I hope this works. Can you hear me, David?
Yes.
Excellent. Thank you so much for your talk. I find the strategy work that Incose has been doing inspiring. And when I heard you speaking about the increased complexity and change that we face every day, it made me put down another word that starts with C. And I just wondered if you had any thoughts about how conflict comes into this space and what that even means. I mean, we talk about being conflict savvy people, and we talk about problems often being people problems, but there can be all kinds of dimensions to conflict. What are your thoughts?
No, you're absolutely right, Grace, and thanks for bringing up that C. As systems engineers, we often think of conflicts in terms of technical requirements. We think of it in terms of stakeholder desires. To be honest with you, Grace, I probably have not thought of it at the scale I should have. But I will say that as we think about conflict at a product-centric level, it is much smaller scale than when we think about conflict at a societal challenges level. There is a conflict between not only people, but ideas and worldview. If you take a societal goal, a UN Sustainable Design Goal of no poverty, that is not a stakeholder perspective problem. That is a worldview problem. And if we're going to really solve that, it perhaps requires thinking and communication at one of the hardest levels. If you and I have a common worldview, then you and I have an ability to communicate, because the framework within which we're exchanging ideas is at least common. We may have different opinions, we may miss language, etc. We may have different priorities, but okay, we can still communicate. When you have people with two different worldviews, they can use the same words to mean completely different things. And that becomes a fundamental problem when we're talking about sustainable design goals. Now we're across cultural boundaries, we're across value boundaries, et cetera. So I think we're going to have to deal with conflict at a different level, which means, among other things, we as systems engineers are not fully equipped for it. how do we engage the people who can help us understand that level of conflict at the depth necessary? Because it's more than just being an expert in thermodynamics and software, et cetera. Social sciences and psychology and economy and all those words, those are the big words that we have to deal with. And it's a different conflict than what we know. I hope I started to touch, Grace, and I'd love your thoughts on that as well.
You did, and it makes me think about some of the work being done in the social systems working group.
Mhm.
And I just wonder how that, will mature. I find that exciting work.
You're correct. And I'm glad you find it exciting, Grace, because I think whether we're dealing at the product level, enterprise level, or societal level, we as engineers are going to have to lean into the social sciences because it is a human-centric world. It is Society 5.0. Even if we're building a product, what is the interaction between that product and the intended operator, the human, the stakeholder, the unintended impacted person? We have to look beyond hardware and software. We have to look to wetware. And we have to understand that in a different way. And society, social systems is the place that we're going to learn that. Thanks, Grace. Jeffrey.
Yes, David, thank you. I enjoyed the talk tonight. And I wanted to ask you your thought about the future vision for systems engineering in a complex or overly and increasingly complex environment, especially give consideration and respond to future challenges where AI will be writing requirements and changing solutions on the fly with humans out of the loop. How will systems engineering be different to handle that future state?
It's a real interesting question, Jeffrey, and I appreciate you asking it. With some of the stories that you're seeing about the latest Chat GPT-4 and its ability to very quickly generate a website, a web capability from a sketch. And we're talking about things that have been talked about and demonstrated here in the last 36 hours. It's easy as an engineer to get a little pessimistic and wonder, do we have a role anymore? Or to get optimistic. And I tend to be optimistic because to me, what AI does is it takes historic lessons and it allows us to leverage those in a way that we've never done it before. But it means that we must have collected the right data, that we must be leveraging the right data, and it still requires the right interconnection level. So there is a place for us as the technical connective tissue to set the right scope, to bring the right pieces to the table, data sets, disciplines, et cetera. So that innovation function is still going to require the human. We, however, are going to have to figure out two things. How do we interoperate with technology in a different way? Because you're right, it can generate requirements. It may generate our SysML diagrams from a sketch. Maybe this workforce problem of I need more SysML trained engineers is not a problem in 2 years. I really don't know. We have to think about that. But the daunting thing is, how do we qualify? How do we verify? How do we validate something that is not at all what we engineered? We may think that we engineered the framework, but because of the learning algorithms and the change in behavior, the way it exists now is not what we verified, is not what we qualified. So we're going to have to go back to first principles and figure that one out. So it is both energizing, it is both scary from a technical change perspective, and it is scary from an impact if we get it wrong. But heck, if it were easy, somebody else would do it, right, Jeffrey?
Yeah, I appreciate it. Thank you.
Thanks.
If that's it, is there any more questions? If not, we're going to close out for this evening. I want to thank David for such a great talk here about Incose's Vision 2035 and the discussion on the future of systems engineering. We really appreciate you giving a talk to our membership here, David.
Great. Truly a pleasure. Thanks for the opportunity and thanks for the great engagement. And thanks for coming back when we had a little technical hiccup. You guys all had a get out of jail free card and you came back.
It's always crazy behind the scenes here. Never a dull moment. Thank you, David. So we're going to raffle your book off here after we log off to the folks here who actually showed up for the membership meeting. But I want to encourage, before I do, I want to encourage you, next month is going to be our first in-person dinner. Like, these guys showed up, there was no food or anything. That's how dedicated they are coming here. So I'm just want to encourage folks to look at signing up for next month's dinner. Get here a little early, cut out of work a little early, and we'll be able to actually meet and socialize in person. So with that, wish everyone a good night.